Hello everybody, welcome to Bobcad's webinar series, the next edition. This is today's topic is going to be about check surfaces versus boundaries. Let's see here. The goal of today's webinar is to provide greater insight and confidence to control where your toolpath is and is not created. Now, as you know, my name is Al DiPaolo. I'm the voice of the Bobcat After Dark video series. You can find me on Instagram at Al DiPaolo. You can also search hashtag Bobcat After Dark. We're going to talk about boundary control. When we're talking about boundary control, we're going to talk about feature versus operation boundaries. You have a feature boundary and an operation boundary. We're also going to talk about supported geometry, what you can use to use as a boundary, whether it's wireframe, surface edges, or loops. We're also going to talk about tool location, where the tool, how the boundary affects where the tool is going to be. Now, the big benefits of boundary control or using a boundary for your 3D toolpath is it limits where the toolpath is created by the selected boundary. So you select the geometry you want to work with, you select the boundary, and it gives you the ability to control where that toolpath is going to be generated. All right, the other topic we're going to talk about today is gouge check with check surfaces. We're going to look at multiple surface selections, so you can select multiple surfaces to use your gouge checking and check surfaces. We're also going to talk about trim and retract, the two different options that you have when you're using your check surfaces and different ways that you can use them. We're going to talk about allowance, how allowance plays a role in using check surfaces. Now, the big benefits of the gouge checking with check surfaces is it simplifies the user's control of where toolpath is created. And keep in mind, you can combine both boundaries and check surfaces for the ultimate control. Now, we do have a special offer for today's webinar attendees. Whether you're an existing customer, whether you're a potential customer, the sales team has put together a really special offer for you. So in order to take advantage of that offer, you do need to call into this number here. It's 877-333-4903. It's a special phone number for a very special offer. So keep that in mind, guys. Again, with the Bobcat CAM software, you got fewer steps, better cuts, and more profit, okay? Now, hold on just a second for me here while I get my screen set up. And we'll go ahead and get started. We're going to jump right in. Now again, any questions you guys have about 3D machining, go ahead and just type them into the question box down at the bottom. You can type in any question. Every question is a good question, so anything that you guys can think of that you're interested in learning about or you have questions about, just go ahead and type that question in there. All right, so let's drop our first file in. This is the first file that we're going to work on. Let me go ahead and delete this feature out. This is in the Bobcat version 29 software. This is the model that we want to work on. And again, the goal of today's webinar is to provide greater insight and confidence to control where toolpath is and isn't created, okay? The problem that we're trying to address is if you ask yourself, have you ever struggled keeping your toolpath away from specific part features or maybe even work holding? In today's webinar, we're going to look at two different features to control your toolpath, and those two features are going to be the boundary control, and then it's also going to be using your check surfaces, okay? Now, so the first thing I want to address here is boundary control. So I have my model, I have my job set up, I have my zero set up, okay? Everything's ready to go here. I'm going to load in my toolpath. So we're going to do a 3-axis. We're going to select our model here. Okay, we're going to go to our machining strategy, and I'm just going to use the advanced planer. Okay, I'll set up a ball mill. The default is fine. The lace angle we're going to set to 0. Step over is fine. I'm just going to drop down the machining tolerance, and I'm just going to compute some toolpath. Now, if you guys have watched the 3D boot camp or if you haven't watched the 3D Bootcamp, I do recommend you watch that webinar. It does cover a lot of topics about controlling your toolpath. But again, in today's webinar, we're talking about boundary control and check surfaces and the difference here. So we have our toolpath driving along this model. We can backplot this. You can see it moves back and forth over all the geometry that we've selected. So the first thing that we want to talk about is the boundary control. Okay, so where do you select the boundary? If we wanted to limit the toolpath, where the toolpath was cutting on our model, what we would do is, one of the things that we would do is we would use a boundary, okay? So when you look at the feature in the tree, okay, so you have your feature, you'll notice there's a feature boundary, and then we have an operation. You'll also notice that there's an operation boundary. So real quick, just so everybody's on the same page here, the feature boundary would apply to all of the operations that you load in. So with this feature, if you had multiple operations, that would be the boundary that would be used for all the operations. But you'll also notice that at the operation level, you have a boundary, okay? So you can either use a main boundary or you can use an operation boundary. And the idea here is to limit having to select the same boundary over and over again if you're going to apply it to multiple operations. Okay, so hopefully that makes sense. I'm sure it does. Now, so let's look at some of the geometry type that you can work with for a boundary. Okay, so if we come in here and we go to our boundary and we right-click and we choose Reselect, right now the only thing that we have here is the solid model here. So let's go ahead and just select this surface, hit our space bar, and recompute our toolpath. Now you will notice that it did trim the toolpath away from this model here, but again, that's typically not the methodology that I would use. I would generally not pick a surface to create a boundary, but you will find in some cases that you can get away with that, all right? More often, what I'm going to use for a boundary is I'm going to come to, let's say I wanted to isolate this tapered boss here, I might come to the edge of that model here. So I'm going to come to the edge. I'm going to turn my shading off by hitting S on my keyboard. I'm going to come over that edge and I'm going to right click on that edge. And I'm going to get two different options here. I'm going to get constant Z, or I'm going to get a loop selection. Now if I go to constant Z, what that's looking for is all the geometry that's at the same Z level. And as you can see in this example, it doesn't select all the way through because we're on a curved surface here. Okay. The other option that we would have would be a loop selection. So if we right click on this edge and we go to loop, you're going to see there's two different options that are highlighted. There's this section in here, okay, where it goes up and over this edge, and then there's also this outside selection here. Now the trick with the loops is not to pick the same edge that you started. You need to either pick one that has a different edge than you first started, and it would either be this edge to get this containment here, or it would be this edge to get this containment here. Okay, so in this case I'm going to click on this edge and you'll see that it went all the way around that edge. Okay, so it selected that loop there. So let's go ahead and hit our space bar to lock in our selection. We'll turn our shading back off. We'll recompute our toolpath. And what you're going to see is this toolpath is now limited to the boundary that we selected. So this is the boundary that we're working on, which is right here, and then our toolpath is being limited to that boundary. So instead of it cutting across the entire model, you can see that it's only cutting inside of that boundary. Okay? So where is your boundary located? It's either located at the feature level below geometry, or it's located below your operation. Hopefully that makes sense. All right. Now, when we're talking about supported geometry, we're talking about either using surface edges. So I showed how to use a loop there. If we remove this, we could, I picked the surface. That was one way that we did it. You could pick the surface, but again, generally that doesn't give you the control that you're really looking for. We're going to remove that. The next option you can do is to pick around the surface edges that you want to work with. okay? So you can pick around and pick multiple surface edges, and you can recompute, and you can see that limits the toolpath then. Another option you can use when you reselect, you can right click on this edge and choose constant Z or a loop. If you choose a loop selection, you just don't want to choose the same edge that you picked initially. You want to pick another edge that would represent the loop that you want to work with, okay? So all of those methods will work for boundary selection. Another option you could use as well if you want to go to wireframe is I would create a new layer. We could do extract edges, single, project to Z0. We can come in here and project a plane down, and then now we can use that that wireframe as a boundary. Okay, so these are, you can work with wireframe, you can work with surfaces, you can work with surface edges, you can work with constant Z, you can work with loops. So these are all the geometry inputs that you can use. Now, it's also important to understand that even if the geometry isn't flat, okay, so if I come in here, let me remove this boundary and reselect. If I pick some of these edges here, even though they're in 3-axis, or it's like a 3-axis curve, we can use those boundaries as well. Okay, so whether you're using the surface edge, the wireframe, it could be flat, it could be curved, it could be up and down in Z. So hopefully that makes sense for everybody. So that covers our supported geometry. Now the next thing that I want to talk about is the control of your boundary. Okay, so we selected a boundary, and as most of you know, the center of our tool is being driven to our boundary. So when we look at the toolpath that's being created here, the center of our tool is being driven to that boundary. Let's remove this. Let's come to this top edge here. We'll do constant Z, spacebar to lock it in, recompute. So we have this toolpath, and as you can see, per that boundary, the center of the tool is going to that boundary, okay? So in some cases, that's going to work just fine. In other cases, you may want it to extend outside of that boundary, or you may want it to come inside of that boundary. So if we edit our feature and we go to options, this is where you're going to see the limit control on the boundary, all right? So we can go to the center of the tool, which is the default. We can say tool inside with an offset. We can say tool outside with an offset, okay? So if we say tool inside, what it's going to do is adjust that boundary, basically half the cutter, so the tool is staying inside of that boundary, okay? So you have tool inside control. If we come in here and we edit this, we go to options, we can say tool outside, we can recompute that, and then you can see there's tool outside control. So now we have the tool going outside of the boundary. Okay, so when you're using these boundaries, you have tool center by default, you have tool inside where it stays inside the boundary, and then you also have tool outside where you have the tool go outside of the boundary. Now you'll also notice that there was an offset option in there. So if we go to our options and we have an offset amount, we can give it an offset or tell it how much further we may want it to extend outside of that boundary. Okay, so here we selected the top edge. This is the boundary that we're working with. We said go outside, and then we gave it an additional offset amount to go even further outside of that boundary. Okay? All right, so hopefully that's clear. You have your boundary control under the feature, under the operation. Okay, this allows you to use a different boundary for your feature or a different boundary for your operations. If you're using the same boundary for everything, you can select it once and then move forward. Okay, we talked about the supported geometry. You can work with wireframe, you can work with surface edges, you can work with loops, you can even work with surfaces. All of those are available inputs for your boundary. Okay. The other thing we talked about is the control for center, inside, and outside. You can have the tool go to the inside of the boundary or the outside of the boundary, and you can offset. Now, we did get a question that came in here. What if you want to cut the curved surface? So let's go ahead and take a look at that. Let's remove our boundary here and recompute our toolpath, and you can see the toolpath is cutting across the model. All right. Now, if we want to limit the toolpath so that it doesn't cut this area here, if we come in and we select our boundary, let's go to our wireframe, for instance. We can select this shape and this shape, and we can compute that toolpath. And then what you're going to see, let me turn my options off. Let's go back to Tool Center and recompute. What you're going to see now is the tool is going to the center of the boundary. So it's cutting the curved surface, and then it's cutting to the center of the boundary. So it's going from the outside to the inside of the boundary. Now the thing is, we may want it to stay further away from this wall and not right up this surface here, okay? So that's where what you might do is offset some of this information. You might offset that boundary a little bit further. You might offset this boundary a little bit further. Okay, so that kind of gives you a little more the reach, you know, as far as what the containment is. You can change it by coming in there and using the wireframe boundary. So now I can keep it away from that wall, and I can have it drive up to the edge of the surface. So hopefully that makes sense. Now, keep in mind, today's webinar is about boundaries versus check surfaces, okay? So I want to cover some of the basics of the boundary control and how that works. So we talked about where it's located, we talked about feature boundaries versus operation boundaries, the supported geometry, and then controlling center, inside, and outside. So does anybody have a question about that? If you have a question about that, if that's not clear to you at this point, go ahead and raise your hand. If it is not clear, Ron says it's not clear. Terry says it's not clear. Terry Rinker says it's not clear. Okay, what if there is something that is unclear about using boundaries to limit your toolpath? Go ahead and type that question into the question box right now. Okay. Let me see here. Let's see if Terry's got Terry Brooks has a microphone. Terry, can you hear me? Do you have a speaker or a microphone over there? No? Okay. Let's see if Thomas, do you have a microphone over there? Nope. Okay. All right, no mics. If you, let me clear everybody's hand. If you still have a question about this and you have a microphone, go ahead and raise your hand. Oh, let's see. Somebody here. Hold on. Who do we have? And again, I really want to thank everybody for showing up here today. Alex, Rodriguez, Adam Suka, let's see, Anthony, thank you so much. Barry, Brian, thank you so much for coming here today. Let's see. Brian, are you there? Can you hear me, Brian? Do you have a microphone, Brian? There we go. Hey, how we doing, Brian? Can you hear me?
Affirmative.
All right, buddy. Okay, so was there any questions you had about the boundary control here as far as how we're using this, where things are located, the geometry you can work with?
No, I'm good, Al. This is Brian out in Kool-Aid, so you might have me mistaken for somebody else.
No, that's totally fine. You're in Kool-Aid, huh? How's the weather out there? Pretty good?
Yeah, it's actually excellent. I just wish it'd stop raining intellects, but that's a whole different topic. I do have one quick question now.
Sure.
With regards to the boundaries, you know that I do some very unique 3D stuff with wood.
Right.
And a question that I mentioned to you probably a couple of weeks ago during one of the seminars is when there's a 90-degree angle, for an example, what you have up here on the screen, if we were to turn this on its side and you were coming down, in fact, go to your X, make your X to where it's upright, because what I'm getting at is if you're cutting straight down on this, you know, even though this has a curve, and I was coming straight down on that, like right now, say we're looking at it from a Z perspective, coming down on that to cut this right where the tangent curve is on your center portion, that example I gave you of that elephant seal, I was struggling to find the trade-off between not touching that edge that your cursor is on currently and that inner edge using, say, I was using or attempting to use a 1/8 inch end mill.
Right. Okay. Now,
does that make sense?
I believe we're cutting along this surface here. Is that correct? And
yes.
You want to stay away from this edge?
Yes.
And you want to stay away from this edge here, or no?
No.
Okay.
Actually, I want
to. Is this a tapered or a straight walled? So you're doing like a Z-level finish? Did I lose you?
No, I'm still here. This damn mic cuts in and out, and that's why I don't use it that often.
Okay. So you're doing like a Z-level finish on this?
Actually, that wasn't the part I was trying to cut. The center part is actually what I was trying to cut. That was kind of representing, say, that elephant seal that I was doing.
Right.
So I would be coming down, and the part that you have the boundary on would be like the base that I don't want to cut. But I want to be able to define like a front flipper or just some detail on this object. But trying to find that balance and that trade-off between touching the part and not touching what I would say is the foundation, so to speak. Man, I struggled with that for hours.
Well, and did you utilize the check surfaces?
Well, with it being a solid model, that's what I struggled with, because the STL I have, I had to create the base and put the solid model on it.
Right.
So yes, using the check surfaces from that one seminar was extremely helpful. And then you and I, we spoke on the phone.
Right.
It made it was just challenging, to say the least, because trying to find that trade-off between, and you've mentioned this before, Al, is, you have to do one thing, compute it, see how it reacts, do one thing. Again, I spent hours trying to find the balance between not touching the base of the part and still getting the detail I wanted on the 3D object I was trying to cut.
Yeah, no, there definitely is a balance, and that's really the main point of today's webinar, is really showing you how the boundaries work so you understand those, but then also how the check surfaces work as well. And sometimes it's a combination of both, but it does take a good understanding of the check surfaces and the way that they work. So hopefully as we continue on here, it will bring some insight to that. And again, we can always work together after the webinar to go into more detail. Okay, Brian?
Yeah, I appreciate it, Al. Thank you much.
Thank you, bud. Thank you. Okay, so it looks like we're pretty clear with our boundary control at this time, and let's move forward to the next topic. Okay, so the next thing we're talking about here are the check surfaces. So what I'm going to do is I'm going to remove this boundary control here, and I'm going to recompute my toolpath. Okay, so the difference really between the boundary control and the check surfaces has to do with what your input geometry is. Okay, so again, if we want to limit, instead of limiting where the toolpath is being generated, we're going to use our check surfaces to say we're making contact or we're getting close to this surface, and then what do we want to have happen. So the first thing we want to talk about is where are the check surface located. So if we edit our feature and we go to where it says gouge check, okay, this is where you're going to find the check surfaces. Now, in order to turn it on, you go to where it says check one and you turn it on. From here, you can select the surfaces that you want to check against. You have your allowance value. You have whether you're checking against the tool or the tool and the holder, and then you have the strategy that you're going to use, whether you're going to do a retrack or bump the tool up, or whether you're going to do a trim and a relink, okay? So this is where your check surfaces are located. The type of geometry you can work with check surfaces are, you guessed it, it's surfaces. Okay, so we're going to want to go ahead and click check surface. Okay, and then we're going to select the surfaces that we want to pay attention to. So in this case, what I'm going to do is I'm going to select just the walls of this tapered boss here. Okay, so we're going to select the walls there. We'll hit our space bar. All right, what we want to do is we want to trim and relink our tool path, and I'm going to leave my allowance at 0 to begin with, and then I'm going to compute. Okay, and what you're going to see is really nothing changed, right? And hopefully that's not surprising to you, and it's really one of the points of how the allowance works. The allowance is saying how close the tool can get to that surface, and if I didn't leave an allowance, then the tool is going to drive right to that surface. Okay, if we come in here and we edit this again, and then now we add an allowance amount and we recompute that tool path, now you're going to see areas where it's starting to push back or trim away the tool path. Now these are linking moves here is what you're seeing here. These are linking, okay? These move here are rapiding and then moving over, okay? So as we increase our allowance here, we bump this number up further and further, the tool's going to stay further and further away from these walls here, and these are the walls that we had selected. If you look at it, it's this wall that we selected here. So we're having them go up, go over, and then it's also staying away from this edge, and it's staying away from this edge. Now if we add to our check surface here, if we add this top one as well, okay, if we add that top one as well and then we recompute, then you're going to see it's just going to check out that area altogether. Okay, and as we increase our allowance, it's going to move further and further away from that surface. Okay, so the check surfaces and gouge checking is located within the feature. You're going to see it down here where it says gouge check. The type of geometry that is supported is the surface geometry. Okay, the control that you have is you can either trim and relink, or what you can do is you can bump the tool up where it will bump up and get away from that area. And Brian, that may be the solution that you were looking for, is maybe not trimming the tool path away, but instead using the retract method to bump it up so that you're getting as close to that surface as you possibly can. Okay, so let's go ahead and edit this. We're going to make this number bigger just so we can exaggerate it. Again, using the retract, you can bump it up. It will, this is saying the clearance plane is too low. If you make it too large and it affects or runs into the clearance plane, then it will error out for you. That would require you to come in and to change your clearance plane so that you have room for the tool path to be calculated. We'll drop it down again. The idea here is to show you that the tool path is being bumped up. All right, so here you can see it's being bumped up and staying away from that surface, or retracting away from that surface. And this is really, really good stuff. These are great features to have, because unlike boundaries where you're trying to limit where the tool is being generated, you can actually select surfaces and say, hey, trim away from there, or hey, stay away from there. And that's the thing that I really like about the combination of boundaries and check surfaces. Okay, so the next thing that we want to look at here is what toolpaths offer these check surfaces. Okay, so if we edit this feature here, all of your mill professional toolpaths offer these check surfaces. So you have advanced rough, flatlands, equidistant, pencil, advanced planar, project curves, and advanced Z-level finish. All of these utilize the check surfaces to trim away or to bump up your toolpath. So we talked about boundary control, what's supported, the way that it works, where it's located. We talked about our check surfaces, where it's located, what type of geometry is supported, and then the control that you have on it. And then we talked about which toolpath features have it available, and it's all of your mill professional toolpath features have those options for you. All right, so let's go ahead and you know, if we're looking at this here, again, let's kind of play around with this file for just a second. So at one point we had selected these surfaces here. Let's go ahead and clear that selection. This time we're going to select this surface here, and we're going to go ahead and recompute. And then what you're going to see now, this is where we're bumping it up. So it's bumping up the toolpath away from this surface here and generating our same toolpath. So we're adding like more stock to finish on the bottom there, okay? If we come in here and we, instead of doing a retract tool, if we do a trim and relink and we recompute that, what you're going to see is it's going to trim away the toolpath that makes contact with the check surface that is selected. Okay, so hopefully that makes sense for everybody, and we're moving along well here. All right, so now let's take a look at some more sample files, because I really want to make sure everybody has a good understanding of the way that these check surfaces work. Okay, so here we have another file. We have our toolpath selected. Again, just a planar toolpath. The check surfaces that we've selected were these top surfaces here. Okay, when we look at the option that we have it set to trim and relink, and what that's doing is we're saying, hey, we need to avoid toolpath making contact with these surfaces here, so let's go ahead and do that, and you can see that it's trimming and relinking that toolpath. All right, now another thing that I think is pretty important is has to do with the fact that you can have multiple check surface groups. Like if we get into this feature and we look at our gouge check, you have check 1, 2, 3, 4. And you know, at first, when you first start using these gouge checking, I definitely recommend that you start with just one check surface at a time. Now, Ernesto had a question about, are the rapid lines bumped up too? The rapid lines are going to follow your clearance settings that you have set in your feature. So if you go to the feature, clearance plane, rapid plane, feed plane, these are going to be the options that, as far as where the tool is driven to. Marja said, what about the options to trim and relink? Can you explain which ones to use? So we're going to look at that in this particular example here. Okay, so we have our check surfaces. Again, and what I'm talking about is you can use different check surfaces. So we're going to go ahead and click check surface here, and we're going to remove this one, spacebar. We're going to recompute. And what we're going to see is the toolpath is now driving along the top of that surface here. We have a certain clearance amount that we have set for this one here. Okay, what we're going to do is use a second check surface. We're going to select that surface, which is going to be this one here. We'll use our trim and relink, okay? And then we're going to add a different allowance here. So this is, again, one of the features of using check surfaces that you don't really have for the boundary control. With a boundary control, you can set an XY boundary. So we could go to wireframe and we could set an XY boundary, so you could have it closer to one boss than the other boss. But with the check surfaces, you can select different groups of surfaces and apply different allowances, which I think is a really great feature and gives you a lot of control and flexibility. So we can come in here and again, use different allowances for the different surfaces that we've selected. Let's go ahead and turn that one off and recompute. All right, let's go ahead and we're going to add this surface here. Okay, and recompute, and you can see that our toolpath is generated there. Now, when you go to when you start using the gouge checking and check surfaces, when you go to trim and relink, you do have a bunch of different options in here. If we scroll down, you can see after first collision, before last collision, between first and last collision, trim before first collision, trim after last collision. And what this does, if you use trim collision only, a lot of times that's going to give you a result that is beneficial, but one of the things that you're going to notice here is that we have a lot of up and down tool motion. Okay, so we're making contact and we're going up and down, and that may not be the ideal scenario. Okay, so using some of the different trim options, like we can do trim after first collision and we can recompute, you're going to see that that's going to change that toolpath. So as soon as we've made a collision over here, we're trimming out the rest of that toolpath. So that way we can address those other areas in a different way. Now, you know, another question that came up that I didn't address here, someone asked earlier where the tool starts from. If we go in our pattern page, if you want to change which corner it starts in, you can just click on which corner it starts in, and that's the control that you're going to have for like planar, where the tool starts. And some of the other strategies, it's going to depend on what options are available in that strategy. But in this particular strategy, we can choose which side that we want it to start on just by clicking our start corner, and that's the control that you have there. Okay, so we have our tool path. It's moving back and forth. It's starting in this front corner here, and as soon as it makes a contact to trim out, it trims away all the tool path that's in that area. Okay. Again, what this is doing, when we had that turned off, if we go to trim collision only, what that does is just removes the tool path, and it generates tool path in between here, but we get a bunch of up and down motion, and then, you know, the control that you have to lead the tool in, you know, that is where it may be lacking some of the control that you want. Okay, so using some of these different trim options will allow you to address different areas. If we go trim before last and we recompute, you know, we're going to see a different set. So now it's switched which side that it was working on. Okay, so my best recommendation for you to do is to kind of go through these and just kind of get familiar with them, you know, and the more you use it, you're going to find scenarios where you want to use one over the other. So when you first start, just trim at collision, and then from there you can kind of work through some of the different options and see the effects that it's going to have on your tool path. Again, giving you the control to kind of come in and work through some of this stuff here. Okay, let's see. There's another question. How can I let the tool travel outside the boundary if I need it to? Say I'm cutting a channel on a flat part and I selected my geometry. It won't let me escape that boundary. How do I change this so the tool will be able to go outside of that area? And, you know, okay, so I'm sure, thank you, Jeremy. That's a great question. I'm sure everybody has run into this. I know I've run into it myself quite a bit, where when you're trying to use a boundary. So let's go ahead and let's turn our gouge checking off, and we're going to recompute here, and you see that we have our tool path. The way that this works, let me go ahead and grab one of these loops or this constant Z here. The way this works, Jeremy, in short, is there has to be geometry there, and like surfaces. 3D tool paths are based off of surfaces and solids, and if you want the tool to go outside of that boundary, so if you go to options, we say tool outside, and we say 1 inch and recompute, you're going to see that tool path is going to go outside of that boundary. Okay, so here you can clearly see it's going outside of that boundary. Now, if we want it to go further outside of that boundary, let's go in here, let's make it 1.5, and we recompute, you know, you're going to see that it's going further on this side, but it's not going further on the left side. Okay, and that's because there's no surface. Well, there's a couple of reasons, but there's no surfaces to be driven along there. If you look at under some of your other options, your cutting extents, we have set to 3D extents, or I'm sorry, we have set to extents. So that is another limit that's happening on the tool path. If we go to part bottom and we recompute, you know, what we're going to see now is that it extends past that edge, and then it's also start going down to the bottom of the part. Okay. The other thing that you would look at here is if you say 3D extents, that's kind of like a rollover amount, and that's going to roll over past the edge of the part as well. Okay, so these are some of the options that you're looking for, but I think the scenario you're talking about is where you don't really have tool path to drive that tool along. Again, and keep in mind, the boundary that we selected was this boundary here. So you can see that I was able to get it to go outside of that by using the tool outside, but in order to get it to trim past the edge of this surface, I had to adjust some of my other limits. So hopefully that makes sense for you there, Jeremy. I think that is a great question. So thank you for sharing that. Okay, so what do we got? So we got our surfaces. Let's you know, let's look at some other ways that we can do this. You know, let's remove our boundary here. If we, and we'll recompute our toolpath. So we have our toolpath going over the whole model. If we wanted to eliminate the toolpath from running along these surfaces, we can go to a gouge check, let's remove this one and this one, and we'll select this one here as well. If you guys ever are having problems selecting surfaces, kind of like what I was showing there, sometimes it makes sense just to go to a wireframe view. This is S and W on your keyboard. It will help so that you're seeing the same things that the software is seeing when we're doing a selection. Okay, so we're going to hit our space bar. We're going to trim and relink. We'll go ahead and recompute. And you can see this is a way to limit the toolpath to run along these edges here and to stay away from this surface, okay? So that's, again, when we're looking at using boundaries versus using check surfaces, there's pros and cons to each. When it comes to check surfaces, I think you'll find it a lot easier to say, hey, if you make contact with the surface, bump up or trim away, okay? So I'm glad that helped you out there, Jeremy. All right, let's look at another file here. Okay, let me close this guy down, and I'm going to load up this file here. All right, so the other day I was working with a client, and he had this part he was trying to cut, and we were trying to use flatlands, and no matter what we did, it just would not let us use flatlands, okay? And I was stumped, and I didn't know what it was. And actually what had happened is the surface had a slight taper to it, but it was very difficult to see it. And that was kind of the mindset that I had when creating this sample file here, is kind of showing how you can drive toolpath along surfaces that are in a little different areas that could be a little more difficult to create a boundary for, to keep the tool away from. Okay, so if we look at this model here, I do have this check surface set up. Let's go ahead and turn that off and recompute our toolpath. And you're going to see that the toolpath, this is the surface that I want to cut, and this is the toolpath that's being generated on that surface. Now, when you're doing 3D machining with BobCAD, the surface that you select determines where the toolpath is driven to. So because we didn't select any of these neighboring surfaces, you can see how the tool is making contact with that surface there. You can see how they make contact, and let's go to a front view. So that would be a problem, and the reason why that happened is the surface that we were driving the tool along was just this bottom surface here. So we selected just this bottom surface, and then we generate our toolpath, and it's colliding in these other surfaces because they weren't part of the selection, okay? So if we go to a boundary selection on this, we select this surface, let me clear this. We select this surface as our boundary, we hit our space bar, and we recompute. What happens now is the center of the tool is driven to the boundary, because that's the default. Now that definitely didn't help us in this scenario. We're still running into an error, okay, where we're colliding with this other surface. Well, then the next thing you're like is, okay, let me come in here and let's go to some of my options and say tool inside, okay, and we recompute. So now we're driving the toolpath inside of this boundary, and then it's staying inside. But what you'll notice is when you use tool inside on a boundary, it's offsetting inside on all four sides. So now we're missing material over here, and we're really staying quite a bit a ways further from that wall, so we may not actually even be cleaning that up the way that we want it to. Okay, so this is another example of where check surfaces, it makes it a little bit easier to attack scenarios where you have walls that you need to machine up to, but you don't want to make contact with. Okay, so let's remove our boundary, recompute our toolpath, and from here we're going to come in and we're going to add some check surfaces. So we're going to go gouge check, check surface, and we're going to come in and select the surfaces that we want to keep the tool away from, or if the tool makes contact with these, we want to keep the tools away from that area. Okay, so we're going to hit our space bar. We have our allowance. We're going to trim and relink and recompute. And what you're going to see is the toolpath now is driven along these surfaces here, and they're going to come up right up next to that wall, but they're actually not going to make contact with that wall. And then if we want to make that gap smaller or bring it in closer and closer, we just come in and we adjust what our allowance is. You know, maybe it's a smaller and smaller number so we can get closer and closer to that wall. Okay, so again, these are ways where we can machine difficult to boundary surfaces, or surfaces that would take a lot of wireframe to create boundaries for. Now you can attack them using check surfaces. Okay, all right, so let's go ahead and close that guy down. Let's drop another one in here. All right, so here is another sample of a surface here. We have our toolpath being driven. Let's go ahead and turn off our gouge checking and recompute, and here you can see the toolpath is being driven right to the edge of the surface. So that's a good point to understand, is that when you're using boundaries, the default is the center of the tool goes to the boundaries. When you're using, when you're machining surfaces, the center of the tool is going to go to the edge of the surface when you only select one surface at a time, you know. And then here we can see clearly the tool is going to run right into that wall. Okay, so what we can do is come in here, turn our gouge check on, use a check surface here, select the wall that we want the tool to avoid. Okay, trim and relink. We can hit compute, and then you're going to see now the tool is going to stay away from that wall. Okay, so this is again just another way in which you can, you're machining an irregular surface. This one happens to be a slight taper, so you can't come in with like a flatlands or something like that to get it. So we're going to come in here and use our check surfaces to check that toolpath away. Okay, so before I go any further, I want to do some housekeeping and run some polls here, if you guys don't mind. So let's see what we got here. I want to find out what version of the software you guys are using. Are you running the older software? Are you running the newer software? What version are you guys running? Okay, and it does look like the majority of our users are running the more recent software, or the majority of the attendees here today, which is good to see. What I'm going to do, if you are not, if you're not running the current version of software, and it does look like there's a few of you out there, I'm going to post a link in the chat dialog box. This link you can use to download the version 29. I do recommend you download the version 29 and you start working through some of these features here. Okay, so you go through and learn a little bit more about the check surfaces, because we didn't introduce check surfaces until the version 29, and it does look like the majority of the people that are in this webinar are running the version 29. Okay. All right, so let's go ahead and close that one out. Thank you so much, everybody, for voting. Big group of 29, but we did have some 27, some 28, and some 26. No 21 users, which I guess is a good thing, but you know, great to hear it. V5, you're going to find if you're running V5, V3, V4, V2 for BobCam, you're also going to find that the V6 offers these check surfaces. So again, I'd like to get a good idea of how long you guys have been running the Bobcat software. Are you newer users, or are you long-time users? So I just want to get a good idea of what, you know, the experience level, or who I'm working with here. And it does look like there's a mix between veteran users and newer users. If you're a newer user, definitely sign up for these webinars. We run them on a regular basis. You know, you get a recording of the webinar, or the new, I also do a shorter version, so it's just the highlight reel as well. So those will be made available to you as well. But it does look like a good portion. We have a good mixture of users there. So I'm going to go ahead and close this poll down. Thank you for everybody taking a moment to answer that. Let's see, the next one that I have here for you is, what is the preferred way that you guys like to get tips or information, news about CAD/CAM? Do you prefer watching videos? Do you prefer reading articles? Is it webinars, trade show events? What works best for you? As far as consuming this information or getting news, and it looks like a very close race between videos and webinars. A couple of article guys there too, but I'm not sure. I don't know who's going to win, webinars or videos. I think it's going to be webinars, which is really cool. All right, I'm going to go ahead and close that down. Thank you everybody for voting. All right, let's see, what else do I have here? Where do you search for CAD/CAM tips? Now this is really important. If you use forums, then write down which forum you search for. If it's magazines, write down in the question area, write down what magazines you use. So if it's a forum, is it CNC Zone? Is it Practical Machinist? Is it, there's a bunch that are out there. Which forum are you in? If it's a magazine, which magazine? If it's a Facebook, there's a lot of, a lot of you may know me from the forums that are out there, but there's a lot of Facebook groups that are out there as well. So if it's from Facebook or YouTube or an email newsletter, whatever works best for you guys. If you're choosing a forum, please write in the question area what forum you're using. If it's a magazine, please write in what magazine it is that you guys are reading. And it looks like pretty much by a landslide, it's YouTube videos is what is definitely most popular, and I would agree. I spend quite a bit of time myself on these YouTube videos. So let's go ahead and close that one out. Good job, everybody. Let's see, the last one that I have for you for today, this is a really important one for me, is when you're evaluating new software, what is most important? Is it the demo? When you download a demo and you get to play with it and work with it yourself? Is it a one-on-one demo where you work with an applications guy like me and we go through something together? Maybe you send us a part and you want to see how it's done. Is it online reviews where you're searching for a new product and you go online and you see what other people have to say? Or do you have to have a friend's recommendation? This is what I use. You should use this as well. Okay, so just to get a good idea of what works best for you, I think me personally, I'm like a researcher. I tend to do a lot of research, so I look up and I see what other people are doing. At the same time, I do like to get my hands on products as well, so I'm probably a combination of reviews and a demo test drive, me personally, but whatever works best for you. I really appreciate the input, so I'm going to go ahead and close that one down. Thank you so much for everybody voting there. Okay, so we got about just a few minutes left to stay. I always go over. I don't know why. I can't help it. This stuff's so much fun. I probably talk too much. If you feel I talk too much, go ahead and raise your hand. What else do I have to do? I can only talk to you guys, so all right, cool. So let's go to all right, so we have this file here. The other thing that I wanted to talk about, so we did this, we used this surface here and we used an allowance. I think it's very important to understand that if I select another surface here, let me go ahead and select this surface here, the effect that selecting that surface will have on the toolpath, okay? So if you see the toolpath right now, you can see it's going right up to that edge. If we zoom in here, you can see the toolpath goes right up to that edge. By adding this other surface here, this angled surface, as part of our check surface, right? What's going to happen? Well, what do you think is going to happen? Raise your hand if you think it's going to do nothing. Okay, nobody thinks it's going to do nothing, and I would agree. Or well, maybe Walter thinks it's going to do nothing. I don't know, Walter. I think something's going to change. So let's go ahead and recompute here, and something did change. You can see that it bumped away from the edge of that surface as well. So this is the surface that we selected. We had an allowance, and it will affect the edge of surfaces as well. So you keep things away, all right? Really important to understand, and that's really what this particular sample was about keeping the tool away. Steve has a question. If you use a ball nose bit, why would it change? It wouldn't touch that surface, would it? You know, I think it actually does touch that surface, Steve. If we or it's not that it touches that surface, it's that it's within proximity of that surface. It's within the allowance amount of that surface, and that's what you have to pay attention to. Al, if you need to cut that center vertical wall sharp now, would you how would you do that? This vertical wall sharp, I mean, you know, it's on an angle here, so you know, it's tough. It is flat along this edge here, so I think the best you could do is maybe profile with an end mill to get a finish there, and you know, you may have some material left here, so you might step down to a smaller tool to kind of clean that up. Okay, so that's probably what I would look at there. So let me close this file down. Let's see here. I'm going to skip this one. I'm going to go to this guy here. This is just another example of using check surfaces and the way that you can use them. Let's go ahead and remove this. We're going to get rid of our, oops, hold on. Let me turn that off and recompute. This is an area where we can see this is the surface that we've selected. When we're driving our tool path, it's driving right into the model. That would be a problem for us. Charles, I don't think you can use a negative allowance. Well, I'll have to check that in just a second to try to get it to go outside of an area, maybe is what we're thinking there. Not sure. All right, so we have this area here, and again, this is a scenario where if we come in and we select this and we recompute using a boundary, the tool center is being driven to the boundary, so you can see it's still colliding with our part. If we come in here under our options and maybe we said tool inside, you know, maybe we can get the tool to be inside of the shape, but again, when we do that, we're not actually cleaning up all of the surface area there, okay? So then, so if we get rid of the boundary and we recompute, this is again another scenario where check surfaces come in really handy. We can come in here, say gouge check, check. We can select this inner wall here. We want to stay away from that, and we can select the outer wall there. We want to stay away from that, okay? So those are the two surfaces that we want to check against. Here we're going to do a trim and relink. We recompute, and you can see that it generates some toolpath to come in here and just machine that area. The other thing we could do as well is maybe not trim and relink. We could retract the tool, and this would drive that tool along those surfaces and kind of bump them up to stay away from those walls. All right, so hopefully that's pretty clear as well. You know, I'm not sure really how to do, I'm not sure what it would do if we set a negative allowance. I think it just doesn't do anything because you're saying how far you want to stay away from a surface. So I don't think a negative allowance, I mean, I don't think it did anything. If we add our allowance back in, you know, then you can see that it bumps up and away. Let me try a trim and relink. Let's do that. We'll do trim and relink minus 100 thou. You know, I'm not sure. I'm not really sure. It did something, but I don't believe that that's what its intention is for, or I'm not sure how that intention would work. Okay, Charles? So hopefully that answered that. Can we use gouge check as a poor man's cutter comp? I wouldn't look at it that way, but I would use gouge check as a way to keep the tool away from a wall or other surfaces, Rob. So I guess in some ways, sure, you could use it that way, but I wouldn't really use that same terminology there. Okay, so so again, just another example of using check surfaces. Now, for you that stuck around, I think you're in for a little bit of a treat. Here we have just kind of like a prototype part. We have some fixturing that we're working on. This is some of the more complex surfaces, okay? So this is another example of using check surfaces. Now, what I'm showing you here is not done with the mill professional toolpath. This is done with the multi-axis toolpath. This is a surface-based toolpath, okay? So as you go from mill standard to mill pro, you unlock more features. As you go from Mill Pro to multi-axis, you unlock additional features, okay? Some of the questions that people ask, have to do with lead in and lead out and retracts and additional control over what happens when you're dealing with check surfaces, and that's where you're going to find these additional options. Again, you have your check surfaces here. This is where you can use check surfaces for tilting and things like that. So as you get into 4-axis and 5-axis, you'll start using these same concepts that you're learning in 3-axis, you're going to be able to learn and use for 4 and 5-axis, okay? The other thing you'll notice as well is when you get into your linking, you're going to have a lot more control over your linking. So you can say what happens in gaps or as it trims out. Do you want to use a lead in and do you want to use a lead out? In this example here, what I'm using is this wall as my drive surface. This is my edge curve, and then you can see the toolpath is coming down, and then in order to keep it away from what's holding it to the fixture, I'm using check surfaces to check that toolpath away so that it doesn't cut through the tabs, okay? So that's just an example of ways that you guys can use check surfaces there, okay? So now everybody that has joined today's webinar, if you haven't downloaded a demo copy of the version 29, I definitely would like for you guys to do that now. Use the link that is in the chat dialog, okay? This way, you can download the most recent copy of the software and you can start playing and learning with some of these features here, okay? The other thing is for everybody that's attended today's webinar, we do have a special offer for you, whether you're an existing customer or a new potential customer. You need to call this number. It's 877-333-4903 in order to qualify for this special promotion. I don't know what it is. I know that it's something really great and you guys are going to really appreciate it, but you got to call this number. So if you haven't downloaded the current software, use the link that's in the chat. And then if you're looking at, if you're not running 29 and you would like to or would like to learn more about it, definitely call this number for today's special offer. Now, if there are any other questions that you guys would like to ask, now would be a great time to ask for it. It's right at the 2 o'clock mark. I'm going to go through, and again, I really appreciate Adam. Thank you so much for spending some time with us here today. Alex, Anthony, Brian, we had lots of Brians. Chad, Charles, Craig, Daniel, David, thank you so much. Donnie Hicks, good to see you. Ernesto, thank you so much for joining us here today. Hugh, James, Jared, Jeremy, Jerry, Joe, Joey, John, thank you so much for coming here today. Lots of Johns. Johnny, good to see you. Ken, Kevin, thank you, Kevin. Kevin Ponder, nice to see you in here today. Larry, Linda, Mark, thank you so much for attending here today. Peter, lots of Peters. Randolph, Ray, Regional, Rich, thank you so much for coming with us here today. Look forward to seeing you in the next one. Again, any questions that you guys have, please chat away. Please show the link in the chat box. Let me, this is the link. If you didn't get the link, I just put the link in there, so you should have it. Let's see here. Brian, did you If you see the link, let me know if you see the link, Brian. No. I think I just sent it to you. Jerry, you see the link. Brian, I replied to you directly, so you should have that link to download the version 29. Let's see. There's a couple of questions in here. I want to make sure that I addressed everything. Choosing the initial milling point, Alex, again, you use that start corner. That's how you pick up the initial milling point. Boundaries. There was a, Joey, I didn't get to the mill between the boundaries. I'll email that to you directly. There's some things in there that that you can use. Thom has left. I'll end up emailing him. Let's see what else we have. If I'm cutting a large round bowl cavity and I want the cutter to spiral in, how can I control the location of the spiral? These sound like more start point locations. In the advanced rough, you can use a drill tip position in order to pick a start point for a shape like that, Ron. So again, it's pretty easy to handle. Just look at your advanced rough and drill tip position in order to pick a start point for that. Yeah, let's see. Steve, there was a question about a ball nose. You could use a ball nose, a bull nose, any kind of nose you want to use there. So yeah, I'll probably end up emailing you anyways. Haven't talked to you in a while. Let's see if there's anything else here that needs to be addressed. Again, thank you so much for everybody attending. I know there's a few of you still left in here. If you, make sure to let your friends, family, co-workers, everybody know about this kind of stuff, these webinars. We're trying to do more and more of them, so the more people that show up, the more that we'll do. Extended version, yeah, sure. Thomas, I can send you the full version. Steve, I don't know if whether you use a boundary or a check surface depending on the bit. I think it depends on the application. Joey, thank you so much for your feedback. You're welcome. All right, guys, I'm going to shut it down for here today. Thank you so much for joining. Look forward to seeing you guys in the next one. Don't forget to call 877-333-4903 for today's special offer. Also, if you haven't downloaded the version 29, please go ahead and do that here today. Use the link that was posted in the chat dialog box. That'd be great. Thank you, John. Thank you, Steve. Thank you, Ryan. Thank you. Look forward to seeing you in the next one. Thank you so much, everybody. Thank you. Have a great day.